hello everybody. Welcome to the Project Outback presentation based from a rigging perspective, and rigging which has been made in the KineFX framework using APEX. So first of all, I'm going to introduce myself very quickly. So hello, my name is Carlos Valcarcel. I'm a character TD, and I'm trying to specialize in stylized character creation. I've worked in many rig and animation frameworks over time. I started in 3ds Max, then Softimage, then Motion Builder, Maya, Houdini, touch a little bit on Blender, and a little bit on Unreal also. I also like to experiment in making UX, or user experiences, more tangible, both in terms of software and hardware. Recently, I've had the pleasure to start mentoring at École NAD UQAC, which is a university in Montreal, to mentor in the APEX rigging framework. This was being asked by students, so we had the opportunity to explore APEX together. And I'm very hopeful that the industry will transition to Houdini very soon. So everybody, we have to make this happen. So a bit more context on my history with Houdini. In 2016, I was in a company called Shed, and we made a trailer for what we wanted to, for a short we wanted to do. But this was at the time when Autodesk killed the Softimage program. Shed was animating in Softimage, so at that time we were looking for an alternative to that software. And we've heard many good things about Houdini, and so we decided to try it out. And SideFX was super cool that they wanted to partner with us to help us in this transition. So basically, SideFX provided us with some expertise with developers to help us learn the software, but also help in some development. And in return, we would give feedback to SideFX about our process, what we learn, and suggestions that we would have along the way. So this, you can see an animation here done by animator David Saint-Amand, entirely animated in Houdini, and the rigging was done at object level at this time. So this is pre-KineFX. So to give you an example of what the rig looked like at the time, this is the character rig, and we can know that this is object level because you can see some little bones all over the place, and they are not necessarily aligned in the way you would think of, but these are the bones that would deform the character at sub-level afterwards. So to do this transition, we wanted to recover familiar reflexes that we had in other softwares. So we recreated familiar menus, numerical entry interfaces, a whole constraint framework, the ability to keyframe in global space or local space. And the partnership that we had with SideFX brought some new innovations also. So the first instance of animation layers came because of this project. Fast forward in time to 2022. Then Rodeo FX in Montreal was trying to develop a new animation division. And I had the opportunity to join this team to participate on a project called Canary. This was also building a USD pipeline at the same time, and Houdini was used in many departments for that project. However, for rigging and animation, it was still going to be under Maya. But I still had access to Houdini, and I used it to prototype many rigging systems that I would have to build into Maya afterwards. So Houdini, to me, became a tool to test some rig logic and to prototype some systems. And it also allowed me to build some blend shapes, because part of the rigging, the facial rigging we were going to do was going to be driven by blend shapes. So here we can see an example of this. Because at the beginning of the project, we didn't know if we're going to have enough modelers to have one dedicated to model facial blend shapes. I previously had done some R&D at home about the order of operation techniques, and I tried to replicate those in Houdini. So I used those techniques to build a facial rig inside Houdini, that would interpolate the way I want, and they would serve as a base to hopefully model blend shapes on top of that. So this gave me already a good range of expression that I could tweak procedurally very well, very easily, I mean. And it made sure that the fall-offs of the effects were very precise, very easy to tweak precisely. So if a modeler would sculpt over this, I already knew that the speed of the points, the way they move, was already going to be a good starting point. So once I had built that, I could then split every individual shape. I could split into very local regions to have a facial rig with a maximum of local controls. So here we can see each blend shape being activated one at a time. So they are splitted blend shapes. So sometimes it's just left and right, but most often it's in 3 regions: inner, mid, and outer regions. And here I want to also show an example of a user interface experiment that I was doing with Python viewer states. So the idea was to replicate what we often see in big studios making ofs, where you see them interact with the rig in a very different way than that we're used to, where they just push on the mesh and it activates the rig. So I thought, maybe the Python viewer state is a good place to investigate this. So effectively, it was quite easy to put some attributes on polygons to define some regions that would correspond to a controller, and then even put some sub-regions inside it. So we would, in that way, enhance the discoverability of those zones as we move the mouse over the model. Then there would be events that would be available to trigger when we click on those zones, or double click, or mouse wheel, control click, whatever combinations of keyboard shortcuts you could catch and activate an event based on that. So in this case, when I move the mouse, it would know which controller to move, and it would activate it, move the parameters, and this would deform the rig afterwards. So this is the best experience I've had manipulating a rig. It's super fast, it's super intuitive, it's fun to do, and it's very powerful because you can activate easily, let's say, a mirror mode, and the mirror mode can be absolute mirror or relative mirror. I look forward to maybe implement this in Apex eventually. I'm sure there's a way to do this. And now if we fast forward again to 2025, we go to Project Outback. So Project Outback is a side effects project. The goal of the project was to provide some assets for a workshop, for animation workshop. So we would provide rigged characters and environment, and then the community could play with those assets to try animating with them, or to investigate the rigging scenes to see how they are built. So I will play a quick video of the render shot. So I have to play. So the project is not a short movie, it's not a sequence, it's only 2 animation clips that loop, because the goal, as I mentioned, is to provide those assets for testing. Okay. I'm going to switch back to here. No, here. And I want to mention the concept art and the direction done by Benoit Thériault, modeling, texturing, lighting, and comp by Pedro Conti, rigging by myself, and animation by Camilo Guaman-Gonzalez, who's going to give the next presentation. So the project's rigging objectives are quite simple at the beginning. It's rigging 2 biped characters with KineFX and APEX. So, but this unlocks sub-objectives. So first of all, I need to learn APEX. Then second of all, that means also I need to build a replicable biped rig components with the industry standard features. For example, symmetrical rig behavior, scalable rig with as much local scaling control as possible. I want to provide the usual interpolation spaces. Of course, we want the FK-IK options, foot roll, And I wanted to experiment with a typical deformation graph, so only blend shapes and skinning for now, because I wanted to make a proof of concept for myself that I could replicate the comfort zone that I used to. So if I know that I'm able to do all of this, I know that I'm going to be able to build on top of that afterwards. But I want to at least succeed with this chain of deformation. So all of this means I also need to build a custom rigging framework to achieve those objectives. But before we go further, what is KineFX exactly? So the textbook's definition by SideFX is KineFX is a rigging and animation framework and toolset that allows you to create and edit characters all at the geometry level. So remember at the beginning of my presentation, I mentioned I was rigging at object level. This is what we're used to do in any animation software. A controller is an object. We can transform those controllers, and this will move probably joints, and the joints will deform the geometry. So the words that I'm using right now are very important. Transformation, this is objects we're transforming. Translation, rotation, scale. And in turn, those will deform geometry. But now KineFX tells us that we're going to rig at the geometry level. So that means that a joint is no longer an object. It's represented by a point. It's a point with special attributes. So we're going to have attributes for translation, rotation, and scaling for transform. Even if we're at geometry level, this is not deformation. We're transforming those points. And we also have the notion of hierarchy that we need to be able to represent at geometry level. And this is done by putting a line between 2 points. So we are describing hierarchy with topology. You can see on the image on the right of the screen, this is what the skeleton looks like in KineFX. So the lines represent the hierarchy, and each point is considered a joint. And you can see some small gnomon hats on the joints. So we can see that there's transform attributes there. They have translation, rotation, and scaling attributes. So, but why would we want to do this? Like, object rigging already works well. Well, it turns out that geometry level rigging is going to unlock a lot of possibilities. In Houdini terms, that means that all subs, so subs means surface operator, so operators that operate on geometry, they instantly become available for controlling joints. This means that operators that generate geometry can generate joints. Operators that deform geometry can now deform joints or transform points. An example of that would be very difficult to achieve otherwise is, let's say you want to skin an armature on top of another armature. Then we can easily do this because we're dealing with geometry. Or if you want to put a lattice to deform the armature of a character, no problem. You want to point deform a geometry with another, a skeleton with a different object, we can do this. We can have wrangles to operate on joints. And above all, we have proceduralism, which is well installed in Houdini. At geometry level, we can use all of this to be procedural with joints. So let's go with a great example of this. The animated GIF showcases the prototype for a sticky tool. A sticky tool is a tool that we use often post-animation, often by the animation department or the character effects department. And the goal of this tool is to correct some deformation or to refine the animation. So you could correct some bad deformation, correct some interpenetrating polygons. So the way it works is you click on the mesh where you would like to have a controller, and it's like a controller on demand. So you click where you want it, and it generates a controller there, and it's going to follow the animation. That's why we say it's sticking to the animation. This controller then generates a fall-off around it, and you can pull and push this controller to deform the geometry. So it's kind of an extra layer of deformation on top of the animation. This is very, very useful. So in KineFX, any point can become a joint. And this is what we see in the animated GIF. There's a picking session where I pick some points, and you will see the controllers being generated, appearing, and then we can simply pull and push them. Doing a tool like this would require a few days in a typical package. But this prototype took less than 1 hour to do, and it was already production ready. An example of proceduralism with KineFX is I'm going to showcase some examples of joints generation and how we animate them, and show we can also play with interpolation. So the top of the screen, you see a simple geometry, a sphere. It has then been cut in 3 parts, and you can see colors to see where they have been cut. And then there's an operator that walks on the mesh, starting from a precise polygon, and it's gonna go from edge to edge and put a new point. It's gonna generate a new point on each edge, and it's gonna try to find the shortest path to cover all polygons. So each time we walk to a new polygon, we put a new joint on the edge, and we connect it with the previous joint. This is building a hierarchy. So we end up really quickly with a hierarchy for every polygon, and each joint has a transform from its parent. So what happens if we zero out the rotation along the rotation of the edge, the axis of the edge? Well, then it flattens the geometry for us. And we can animate this flattening, so because we can interpolate from the rest position to the flattened position. And we can also write our own interpolator, so we can have an unfolding that is sequential, so from one polygon to the next, or all of them at the same time. So with the interpolator, we can choose anywhere in between. So because we have access to wrangles, it's very easy to create an interpolator like this and tweak it like we need it. And to prove that this is procedural, here we see the same setup exactly, but with just a different input geometry. So this is a triangulated cube, and we added an extra operator at the end to add secondary motion to the skeleton. So the springy action that you see, it's a skeleton that is springing. It's not the points of the geometry that are springing. We could also do that if we wanted, but this was to show that we can have procedures to drive joints also. But what is APEX with all of that? Well, APEX is an acronym for All-Purpose Execution. So it's a graph evaluation framework that builds and runs graphs, and it outputs their results. In KineFX, character rigs are represented using APEX graphs. So here we see one of the simplest graphs we can have. The first node is inputting some parameters, some data, in our case, 2 floating points numbers. And the second node is an operator, we are adding the values of those floating points. It outputs a result, and the last node outputs the result of the whole graph. So this is what APEX does. It's visual programming to create an operator, and it takes inputs, computes something, and outputs the result. But what does it mean for a rig? Here's the graph for one of our biped rigs. So we see it's a huge graph. If you are used to Maya, this is very similar to what we would see for a rig in the node editor. But here's the difference. This has all been generated procedurally. So with the APEX framework, we can build our recipes to build rigging components, like an arm, a leg, a spine, and it will generate this whole graph for us and manage it. So it's a great way to manage complexity. It's a great tool for us. So now meet Aiko and Joey, the 2 characters of Project Outback. Here is the first level of detail for the rig controllers. So these are the controllers we would use for layout or blocking. Then we add more controllers to have more refining option. So if we wanted to tweak the lines of action, tweak the silhouette a little bit better, we now have in-between controllers on the limbs, on the spine also, and maybe some beginning of a facial, the eye direction is there also. And we have a level of detail number 2 with all the controllers that we get on the rig. So we see that every twist joint is now available. And there are a bunch of sliders to configure the rig at animation time if you need to. So this will hold the IK, FK blend, the different spaces that are available, hiding some visual cues, stuff like that. So rig configuration. But I mentioned that I was building a rigging framework. Why would I build a rigging framework if Apex is already a framework? I'm doing a framework within a framework. The reason is that I want all my rigging components to be compatible with each other and to respect some logic, some principles, and some conventions. Examples of those conventions are naming conventions, axis alignments, the zero pose versus the rigging pose, the iconography in terms of shapes and colors. And examples of principles would be symmetrical manipulation, scalability of the rigs, having limits or no limits on the rigs depending on the style of animation that you want or the style of animator that you are. Maybe you will want limits or no limits. And all of this is implemented with a library of functions or nodes with Apex graph, and all those nodes within the framework should work very well together. Those nodes will create rig objects, which together will enable the reproduction of rigging patterns. It will implement the rig logic, so constraints and solvers. And they can also complement the mathematical functions that are already available with Apex. So on the image on the right, we see an example of a Houdini package. A Houdini package is a way to distribute a tool set to other members of the team. So usually we have the script folder where we hold the Python scripts, the OTLs for HDAs, configs for hotkeys that you want to share, the main menu .xml to enhance the menus. And there are two new folders available now, Apex Components and Apex Graphs. So if you build your custom graphs and components, you put them in the Houdini package, and then you can ship the package as you would ship a plugin. So to understand a bit better the conventions that I'm using, here's my naming convention. The first token is a series of labels to identify the controller or the objects we want to create. Then I have a polarity, which means I encode the side of the object, on which side of the character it is, like left, right, middle, or top, bottom, or front, back, or combination of those. And finally, the numbering of the object, in case we have many. So examples of that would be head, M0, global, TRS, so double label here, M0, eyelid, up left, 0. So having the same convention all over the time really helps to find back objects afterwards. And the reason that the polarity is not at the beginning of the word is because if you sort some objects by alphabetically, it will be easier to recover them. So if you look for an arm, you look for arm, not left arm or right arm. So depending on the preferences of everybody, but this is the convention I've been going with. In terms of axis alignment, my convention is I align the x-axis in the longitudinal axis of a chain, and when there's a hinge, it usually rotates on the z-axis. So that way, it's standard for every rig, and the animator can numerically put some numbers on the required component, and he knows what he's animating without even looking at the viewport if he doesn't want to. So, and this is useful in the F-curve editor, for example, where you can select the Z F-curve and you know what you're driving. An example of the convention that we have also is the zero pose versus the rigging pose. Often it's the same. So when you reset the controllers to 0, and many times it goes back to the rigging pose, which means it's the binding pose that has been chosen to start the deformation chain. This is a great convention because it really resets to what the rigger was working with. However, it can be useful to define a different pose for the 0 pose to enhance the interpolation and to maybe, hopefully, avoid some gimbal lock situations. So in my case, this is what I've been trying to do. So zeroing out controllers that participate in a chain will straighten the chain. So this is very useful to, let's say for fingers, if you want to have fingers pointing really straight, you just zero them out. If you want to make a fist, you know that you just put them to 90 degrees and you will have a good starting point. So it kind of normalizes a rig a little bit. And it makes it easier to share animation between characters that have different rigging poses or different proportions also. In terms of a symmetrical rig and manipulation and interpolation, we can see on the animated GIF that I select the same controller on both sides of the character, and when I transform those controllers, they transform exactly the same on both sides. So this makes it very easy to symmetrize, or to mirror animation, even if you don't have a mirror tool. So let's say you want to copy-paste some F-curves from one side to the other, it should work directly. There are some exceptions for that, however, because there are some controllers where you don't want this behavior. Typically, it's IK controllers that are used in world space, like the feet, for example. When you take both feet and move them to the right, you want both of them to move to the right. So that's why. But most FK and subcontrollers are symmetrical. An example of as much scalability as possible, well, we want, first of all, to be able to scale uniformly the whole character. This could be to match the size of a set, to cheat a shot, but we also want to be able to reproportion a character. So the scaling inheritance that I use in my hierarchy is to, when we scale a parent object, it's gonna scale the translation of the children, but it's not gonna inherit the scaling to the children. The children will inherit the global scaling of a top-level controller like the COG or the master controller. And on scaling objects, I try to provide as much scaling options as possible, so I try to have non-uniform scaling available. It's not always possible, but most of the time it is. In terms of iconography, I made myself an HDA to generate some icons, and those icons will first of all be 1 unit in length or width or depth. This is, I wanted to normalize the size of the icons to make sure that we can reuse them and fit them in space with numbers that are logical with the unit system you're using. So having normalized icon, I think it's really important. And I also made myself an icon that identifies the X, Y, and Z axis. It's the cube, the XYZ cube that we will see very soon. So I encode also by color, so I match the RGB with the XYZ as usual, and then I use the complement of the RGB colors for the -X, -Z, and -Y axis. After a while, your brain understands those colors very quickly. And I also have pyramid icons to show chains. This is very important when you're trying to make a rig symmetrical, in the case where you're using scaling, negative scaling for the right part of the character, because debugging is very difficult if you don't see the transforms. So this enables us to see the real transforms that are being driven. If you rely only on the manipulators to try to see the axis of your objects, it's not going to be enough. Those manipulators often will not handle well negative scaling. So it's really important to have those icons. And here's an example of the libraries that I've been building with Apex. So I have 4 categories: rig fab, rig logic, math, and constants. And these are just a subset of all the functions, the custom functions that have been created. So rig fab is to create objects and rigging patterns. Rig logic is to implement constraints and solvers. Math is to provide more mathematical functions. And constants is to avoid having magic numbers in your code. So magic numbers are just hard-coded numbers there. So when you use constants, it's a bit clearer, and it self-documents your code also. So an example of how we implement stuff in Apex, we have 2 options. We can go with code, with Apex script. So here's an example of how we define functions. It's very similar to Python. And the other way is with visual programming in a graph. So, and this is the real format of Apex. It's nodes and connection between nodes. When we type code, it's going to compile this and convert it to subgraphs. And here on the right side, bottom right, we see where I merge, let's say, graphs and code. It all becomes a geometry in the end, and this is the format that the code is stored. As geometry in a BGO, we can save it to disk and put it in the Houdini package. So speaking of the RigFab library, the RigFab provides functions to create basic objects or high-level system respecting frameworks convention. So here the smaller node is one of my most basic nodes to create an object. It seems that it has a lot of inputs. So we have inputs for all the naming fields of my naming convention, an input for the TRS translation, rotation, and scaling components that we want to promote to the animator. We have the scaling inheritance that we want to employ on this object. We have the shape of the icons, the color, the offsets. So all of these are going to participate in the creation of the object. But fear not, we don't have to use all of those. They are default values. So creating an object can be made just by putting the node there and specifying the name, and that's it. But it's really cool that we can create with many options at the same time. We could also modify those options or those attributes afterwards, after the creation of them, but I find it makes a bit cleaner code to have them at the creation already. So once we are able to create some objects, we can level up and create rigging patterns. So by rigging pattern, I mean rigging systems that we're going to reuse all over the place. So the classic example is, of course, twist joints. Twist joints will align on a line between two control objects, and it's going to distribute the twist along this alignment, the twist between those two objects. So here's a twist between on the y-axis. And we also have squash and stretch on those joints. So we have different interpolation parameters for rotation or the twist interpolation and the scaling interpolation, as well as the translation. We can profile those interpolation with ramps if we want. Other rigging patterns in this animated GIF, we see control panel, sliders. We're going to see an FK chain, IK chain, interpolating chain between the IK and the FK. And we will see bisectors in pink, which are bisecting the angles of the extremities of a chain. And we have twist joints between those bisectors. Another pattern that we use all the time is a control spline. So we start with control objects, and child of those control objects will often be Bezier tangents. So we have tangent objects, which can be automated or not, manual tangents. And the spline is a series of joints that are aligning with the curve defined by all those control objects. And then we can tweak the orientation interpolation, the scaling interpolation, and the translation interpolation also. So here we see an example where each joint is sticking to the curve. They could also be sliding to preserve the length of the curve. So there are many options there of how to build those. And once we have rigging patterns, we can then level up again and go and create Apex components. So these will be like body parts. And these will be the components that the rigger will use in Houdini with parameters to parameterize those components. So this is done with the auto-rig component nodes. So here we have an example where we have a very simple FK chain. So let's say that the bottom cube is hips, and the top cube are the rib cage. I rotate the rib cage, it's staying in place. So often when we rotate this at animation time, we also have to translate it, because there would normally be a series of vertebrae there to distribute the whole rotation along the spine. In this case, we provide less object, but we can generate in between FK chain procedurally in there that is going to reparent the translation of the rib cage. So when I rotate the rib cage, it can then translate automatically as if the rotation was distributed along many vertebrae. So here I'm activating this option, and now as I rotate, it's going to translate the cube at the same time. So having this as a component makes it easy to replicate this in an already built spine if needed. And speaking of spine, here's on our character. So the same example here, I'm rotating the rib cage. It's not translating. Now I'm activating it, and now it's going to translate at the same time as it's rotating. So this can speed up some animation process. And here I'm pulling on the spine. I'm exaggerating the motion to see how it reacts. And I can see the distribution of the displacement, the position of every joint, and I can see the squash and stretch effect. I can test the scaling, and I will also pull the controller on the side to see how it provides a nice curve, even if it's an impossible movement. I ensure it's not like a linear curve. It provides a nice S interpolation. So in fact, as I pull the controllers, it's going to modify the interpolation method that is being used. So when the spine is at rest or near rest, it's mostly linear, but as I pull it further, it really becomes more of a Bézier interpolation. And here's an example for the finger component. In my case, the finger starts with a metacarpal, and it goes up to the distal phalange. And because it's procedural, I'm not limited to 3 phalanges. I could go with 2 phalanges for a very stylized character, or many more if needed. And I also display the scaling to reproportion the fingers at animation time to provide more appealing poses if needed. And here I'm moving subcontrollers to have local control to further refine the pose. And here's an example on the left side of an animation director drawing over some poses made with the rig to challenge the rigger to see if I can hit the correction that he made. Because hands are super important. They communicate a lot. They're very hard to do in CG, so we have to put some extra effort to try to make them appealing and expressive. The next component is interpolation space. This one is called the gyro compass interpolation space. So it's mostly used for tails, ponytails, or a tie on front of a character. It acts a bit like a twist joint in the sense that it's gonna level with a master controller, but it's gonna point in the direction of a different controller in one axis only. So it's really extracting the twist between 2 objects and applying this twist only. So we can see here on the RGB cube how the cube is like a compass. It's turning around, but it's staying level with the ground. So the ponytail that is parented to it is going to rotate with it on the y-axis, but kind of preserve a vertical orientation when we tilt the head forward, front and back, or left and right. So this provides a behavior that is already more natural by default, and it minimizes the chances of having gimbal lock problems at animation also. Here we have an example of an up-vector space for the knee. So the knee should normally align with the direction of the foot, and this is something we can achieve quite easily by just parenting the up-vector to the foot directly. But when we do this, the up-vector travels a lot vertically as we foot roll the foot. So to avoid that, there's extra logic in here to make sure that the up-vector stays at the same height as of the knee and in front of the knee always. So it should be always easily available for the animator, and the interpolation should be already quite good, so minimal adjustment should be needed by the animator. And one last component example is a look at for the eyes. So that we have the classic look at target, where each eye is going to focus, aim at the target. And we notice that when I translate this controller, it's also orienting itself automatically. It's trying to match the orientation of the head. And this is to prevent that, as we animate the character, that the rotation of this controller is out of sync with the head, and then we would have a crossed eye look. So to minimize these chances, we make sure that we can self-orient this controller with the head. And here we see an example where we were previously in IK, and now it's being driven with FK controller also. And we have also visual cues, the blue lines on the eyes. So this is to easily identify to which eye target it's looking at. But if it's in the way, there's also a slider to remove it. Okay, we're going to talk a little bit about facial rigging also. The facial rigging is not finished on this character. I just could do the blinks. But I can still give some examples of what has been done on this project. So facial rigs can be built on many ways. Like they can be driven by blend shapes or by joints and skinning systems. We could use order of operation techniques, UVN techniques. And there are different schools of thoughts on what they should drive or how they should work. Like, are they favoring shapeability and stylization? Or are they based on VSEMs or VISEMs? Or are they based on muscle activation groups like the facial action coding system? Or is it simply a combination of all of those techniques? In my case, I already mentioned I wanted to go with a blend shape system just to replicate older systems that I've worked with. But as the time goes, I'm going to change my ways of doing facial rigs in many ways. I want to experiment with all of them and ultimately build the best system that I can. So here's an example of an SUP operator that helped me in the creation of shapes, a little bit like I mentioned in the beginning of the presentation, but here's a different use case. So when the modeler provides a character, often it has the eyes open because he needs to see the eyes open for approbation of the character and also for just to test the appeal of the character. But at rigging, especially for stylized characters, we want to have a neutral eye. This means a closed eyelids. And generating this blend shape, often there's a bit of back and forth between the modeler and the rigger because there are some specificities that are not necessarily intuitive or easy to build perfectly. So here I built a small SUP operator where there's a picking session of points to delimit the frontiers of the eye sockets and the border of the eyelids. And automatically, it's going to close the eyelids for us, and it's going to color code the polygons so we can see which edges of the top eyelid matches the lower eyelid. So we can then use ramps to fine tweak the position of those edges. And we can also tweak the thickness of the eyelids. Again, for some appeal reasons, the upper eyelid is often made thicker than the lower eyelid. So this system's outputs on the far left the neutral pose, neutral pose, and it also generates 4 extreme blend shapes targets. So we can see the lower eyelid down action, the lower eyelid up action, then the top eyelid up action, and the top eyelid down action, or I don't see well, but those 4 extremes are there. And once we have that, well, we can add the eyelashes because the eyelashes also need to deform. We could simply attach them with a point deform, but this wouldn't guarantee necessarily the best deformation possible. So here in Houdini, I could create a looping block where I attach in the eyelashes to the eyelid just to generate a general pose with them. So to make sure, just to put them in place. And after that, I do a second pass where I simply sculpt them to refine those deformations and make sure there are no jagged edges and that they are in the appealing pose. After that, I can split those into sub-regions to have finer control. So here I'm extracting an edge from the eyelid, and I'm partitioning the eyelid or masking, making a mask for 3 different regions: the inner region, the mid region, and the outer region. And I'm going to use those masks to then split the blend shapes that were created previously. But the blend shapes that were made previously, when they are used in the blend shape setup, they're going to interpolate linearly. So to avoid this, we can also generate in-between blend shapes. And because my eyelid operator interpolates on a sphere, spherically, with a slurp, it means that I can extract in-betweens that are at the correct distance from the eyeball, and it will avoid this linear interpolation through the eyeball. So the result of this is going to be 60 blend shapes. So two in-betweens for the upper eyelid that travels the most, for the up action, I mean, and left and right. It also does left and right. And here we can see the result. So I'm manipulating the eye target, and we see that the eyelids are now tracking the eyeball vertically. And here I can also activate individually the eyelids. And by using the small controllers, I have finer control over those eyelids. So I'm going to go quickly over some APEX strategies that I found along the way. So about the guides system, so the guides is just a skeleton with tagged points on them. So the tagging is there to specify which type of component we want and to which system they belong. So it's like grouping, grouping geometry, but we're using tags. But I'm also using tags to define some values for some properties. So I have some tags with a semicolon on them. So let's say the last one here, hand _ name, semicolon, hand. So this is a property and a value. So I can read those tags and get some values out of it also. So I'm not using them only for grouping. I'm also fetching some values from there. There are other ways to do this. I could effectively put some attributes on those points and read the attributes. But when you're in the tagging process, it can make sense to have them at tag level also to keep everything in the same context. Also, I put some tags for polarity, but this I don't do on the first pass of tags. I do once the guides are mirrored to the other side. I do this as a post process, and I have just a wrangle generating those tags for me automatically, ensuring that all what's on the left has the left tag, in the middle it's middle, and the right tag on the other side. For the skinning workflow, most examples that we've seen with APEX, they start a character with by packing some data. Some of this data is the character's geometry. Then we have often a control shape library for icons, and we have a guides skeleton to help build the components, and we usually have a skeleton to deform the geometry. So the geometry usually is bound to the skeleton with capture attributes. In my case, I didn't want to provide a skeleton there, because I want the rig creation to generate the skeleton for me. So here the purple nodes are going to generate the whole rig, and while it's building the rig, it's also going to modify the character and inject the skeleton as it's being built. So I'm doing the skinning after the rig is being created. So on the right side, we can see this is my skinning graph, and we will zoom on this on the next slides. So this is just a zooming in on the initial character package. So I'm only packaging 3 things: the base shape, the guide skeleton, and the control shape library. So this is the same view, but in the rigging tree, but this is the same thing, 2 views of the same thing. And well, this is in my rig fab node that generates skeleton. So this one has a character as an input. So it takes the whole character because it's going to inject inside it the skeleton. So it's important that I can have this input for this node. So here's we're zooming in on the skinning workflow. So I fetch the rig, and out of it I extract the base shape. I extract the skeleton that has been generated. And from the rig, I also generate an animation for a range of motion. And all of this is going to go in a joint. The first node that I put is a joint capture proximity, just to have a quick skinning in there. And then I just replace it with a joint capture paint, and I manually paint the weighting. This is how I've been used to work my whole life. I don't use much automatic or procedural skinning for that, because I know that any type of skinning I use, I'm always going to review all of them by hand anyway, so I'm always going to paint them anyways. But I do this on the base mesh of the skin of the body. After that, I use more proceduralism to transfer the skinning to other layers, like the clothing, the accessories, stuff like this, and then I can put other operators to smooth that skinning, to layer other parts of skinning, anyway, many options, and often I also put a manual painting on top also. Once all of this is done, the base shape now has new capture attributes, so I just repack it in the original character and it overrides the initial base shape. And for selection sets also, as we've seen in previous demonstration, they are super handy at animation time. They enable you to select or keyframe a group of controllers very easily, or to hide them and isolate them. But right now, this is available in a scene animate node. So it means that pretty much the animator is responsible for them. We can still export them and reload them, but we thought it would be great to generate those at rigging time. So in my rigging scene, I have a scene animate node where I do build my selection sets by hand. And because the selection sets in the end of the day is just a detail attribute on the scene animate node, I just copy this attribute to the character. So now when I package a character, it already has stored them. And we can see here what this attribute looks like. It's a dictionary storing strings, which those strings are also dictionaries inside. So we just have put them on the rig. And at animation time, when we import the character, instead of using the typical Apex scene add character, I made my own node for this. And this is what we see in the green box. It's using inside the typical add character, but there's a second node that then copies back this attribute from the character to the scene. And inside this node, we see a Python node which implements the merging of this scene, of those selection sets. It imports them, copy them, merge them to the available, maybe there were already selection sets in there, so it appends them, and it's going to rename according to the name of the character also. So what are my future challenges with this framework? Well, I would like to also have a workflow to post-edit the iconography manually, because right now the icons are just purely procedural, but sometimes we need to adjust them according to the geometry of our characters. I want to continue the collection of specialized IK solvers like a C-shape solver, S-shape, zigzag solver, or an offset IK plane. I want to speed up the building time of the rigs. I want to, I already experimented with automatic guide placement, so I want to go further in that direction also. I want to test with ephemeral rigs. Animation tools, I want to know how to use them, but also how to make some of them for the future. Also, the need for a character picker would be, it would be really welcome, so we want to test that in future versions also. And yeah, there are many more things I would like to do, but the most important one is explore the new features of Houdini 21. We have a glimpse of what is coming, and it's really promising. But the next steps that are going to happen really soon is finish the facial rig, rig the props of the environment, and playing with including a ragdoll also. So that's it for my presentation. I would like to acknowledge and have special thanks for Fiona Wong, Alasgar Hasanov, Christopher Hebert, Charlotte Rose, Paola Catagno for making this event happen. And I want also to thank Esther Trilch and Henry Dean for their help on learning Apex. And Megan Choret has been discovering Apex with me, so the challenge that she had on her project were very beneficial for me too. And Samantha Youssef, who helped me understand better character design, shape language, and helped me also for this presentation. So thank you very much, everybody. If you have any questions, I will be happy to answer them. Thank you.
Okay. Any questions? Yeah.
Yeah, thanks, Carlos, for that awesome presentation and very impressive tool set you made with Apex.
Thank you.
Are you planning to maintain this and release this or sell it or like become the M-Gear of Houdini in some way?
Well, the initial plan was to make a workshop for this event, but now the event turns out as a presentation. But I think it's still a goal to release those assets and the framework to the community. So we will see how we will do this. So I think we're going to first finish the rigs and maybe update to Houdini 21, and then they will become available. Yeah, so we'll see. For the long-term development, we will see how it goes, but this first version will be available for sure. Yeah.
Awesome.
Assuming he's available, we will be doing a workshop at Houdini Hive Equinox in Toronto on September 22nd, and this will be one of the workshops that we'll do there. Any other questions? Yeah.
Yeah, thank you so much. That was an exceptional presentation. So, yeah, brilliant. It looks like you've invested loads of effort and time into building all of these amazing custom components. It's more of about you. Do you feel like they're finished, or in your eyes, or is there things you want to go back and revisit with some of them? Are there already things you want to go back and change with some of the custom tools that you've made?
Yes, absolutely. I'm quite happy with a lot of things that are there, but there are at some times I had to take some shortcuts, and there are some I need to revisit to finish them. But the most important one is I need to optimize a little bit what I've done. The building time of some of my components is a bit long because, as you know, a character is a collection of packed folders in there. And I'm playing a lot with this concept while I'm generating the skeleton as I build the rig. It means I'm unpacking the folders and repacking at every component. And the same for icons, like all the sliders that I've been building in the 3D sliders. I'm generating those icons on the fly. So I'm packing and unpacking the control shape library all the time. So this adds up in time it adds up a lot. Also, I'm fetching sometimes world positions for parenting and preserving the offset between objects. And because Apex is a graph, it has to know the world position of an object, you need to evaluate the graph. So in order to do that, I'm constantly compiling and invoking the graph to get some world transforms. So I need to find ways to minimize the amount of time that I'm doing this. So there are things I need to improve for sure. And yeah, and the facial rig also, I want to experiment many ways of doing them. So when this is going to be released, it's going to be one way. It doesn't mean it's the best way. It's going to be facial rigs. If every animator seems to want a different facial rig, so it's difficult to find one recipe that everybody's happy with. But right now, I wanted to replicate some old patterns. But yeah, definitely, I want to also make there are many parameters on every of my components. So maybe making a lighter version of them so they are more intuitive, because there are a lot of parameters on them.
It looks fantastic. Yeah, great job.
Thank you.
One of the neat things about seeing these projects come to life is the different ways that different workflows that can be approached. So, Project Violet uses quite a different rigging system than your rigging system, and they're both great, but they're just different ways of doing it. So it's really neat to see today, different approaches to it. Any other questions? Going once, going twice. All right. Well, thanks very much, Carlos. Really, really cool work.
Thank you.